Assalamu alaikum and good afternoon. I am Associate Professor Abdul Rahim Sadiq Bacha, Department of Electrical and Electronic Engineering, Faculty of Engineering and Built Environment, Masa University. I welcome all the participants attending this event. My topic is digital twin. So it's a very, very interesting topic because we all heard about twins. The twins, two children delivered at the same pregnancy, we can call it as twins. What do you mean by digital twin? I'll give the definition of digital twin. Digital twin is a digital model or virtual model of a physical object. So, for an example, a person has its own digital twin. How is it possible? Because nowadays there are many new technologies, Internet of Things, artificial intelligence, development in wireless communication, 5G and cloud computing. The combination of all these technologies create a new technology, and then we have our digital twin. Example, we can create a model of a jet engine or virtual model of a human body of a person or a virtual city of an entire city and buildings. So NASA previously they developed a simulation model before they launched any space vehicle. But there are many failures. But due to the advantage of this digital twin, this error can be minimized. How is it possible? My next slides will explain all these things. So basically, the data from the real world model can be incorporated and input to the digital twin. It's a visual model so that it acts as a physical model. Okay, it uses virtual reality, 3D graphics. Using this, we can create a model. That model can use a process or a system, service, or any other physical object. Okay, for example, our real-time updates can be given as an input to the twins. Twins, which one is a physical model? I am the person, physical object. My digital twin, all my data from me is sent to the virtual model that will react like me. Okay, so it's used for conducting the assessment of the physical system. So any products, process, all can be explained with this. Okay, see here in this slide, there is a aircraft. So I can create the physical aircraft and then a virtual model of the aircraft. All the real-time data can be given to the virtual model so that it reacts like a twin of the aircraft. So what is the difference between simulation? Because sir, we have already simulation. Why we go for this digital twin? Because simulation, we can give the parameters only at the time of the when you give the input. Whereas it will take continuous data, it will analyze the previous data, future data, present data. So, for example, there is a lady sitting in front of me. I will get the data and collect the data, real-time data from her, and I will create a virtual model of her. So, during my analysis, I will analyze after 10 years what will be her character. So, how old is she? So, what is her death line? All this will be determined from this digital twin. That's the wonder of digital twin. Okay, so aircraft and digital twin of the aircraft for weight monitoring, tracking, and weather conditions, how it reacts for different weather conditions. Okay, previously, actually, last time, MS is missing. But if you have a digital twin, there won't be any possibility of missing because twin will predict already. What will happen to this? So this is the advantage of digital twin. So not only used in engineering applications, it is used in medical also. For example, a virtual representation of a physical status of health status of a person, or to create a person-specific biophysical model. So which includes, we can take its heart, we can develop a virtual heart based on the data, physical data of a particular patient, so that we can analyze. So, for example, the next my slide, I will run one video to understand better on this. This video will explain the concept of virtual digital twin.
Imagine a future where personalized healthcare will provide every individual the right type of care in the right way and at the right time. Imagine that every patient has a digital twin, a virtual representation of his health status. Let's explore how this can play a significant role when Mr. Clark, who has been diagnosed with atrial fibrillation, is seeing Dr. Sullivan, his cardiologist. Although AF is a highly prevalent disease, it can be complicated to decide on the Mr. Clark. This is where his digital twin comes in. It starts by using Mr. Clark's medical data to create a patient-specific biophysical model, including a virtual version of his heart, which looks, behaves, and reacts just like the real one. Through a seamless flow of data and advanced analytics capabilities, enabled by Philips Health Suite, Dr. Sullivan can connect Mr. Clark's digital twin with intelligence on similar cases and select ablation as the therapy with the best possible predicted outcome for him, both on the short and on the long term. Dr. Sullivan carefully plans the procedure by simulating various ablation scenarios on Mr. Clark's digital twin. This enables her to select the one with the optimal computed result. The chosen ideal scenario forms the basis for real-time intervention guidance. During the procedure, all taken actions, as well as any unforeseen situations, will process real-time into Mr. Clark's digital twin to redirect if necessary. As a result, Mr. Clark received his treatment at the right time, in the right way, with the best possible outcome. This is one of the many potential cases in which the digital twin adds value to the healthcare system. From personalised diagnosis and therapy selection to procedure planning and guidance tailored to the patient's physical characteristics, medical history, current condition, and future needs. Innovation and you, Philip.
Amazing. Actually, it's a wonderful invention, actually, thanks to the scientific and engineering community. So, not only the digital twin used in medical field and the other fields, especially manufacturing technology industries, for the component level. Suppose you are building a motor engine. So, we have to focus on the critical component within the manufacturing process and creating a digital piece of a particular area of that model and system level in the manufacturing process line. So these are the applications of digital twins in manufacturing. Okay, examples, predictive maintenance, visualize products, enhance product traceability, testing and refining assumptions, remote troubleshooting. Because remote troubleshooting is one of the main area using this digital twin. So the use cases, for example, in automotive industries and setting up a new cities. Because you can build a house, But creating a city, this twin city is, can be possible with the help of digital twins. Okay, weather, wind farm, because nowadays we can see wind energy, the wind farm simulations can be, digital twin wind farm can be modeled using this technology. Okay, so amazing example, Formula One car race. For example, if a particular racer, we can create his model, a digital twin of his racing, so that based on that, we can predict what is the mistake he will commit, how to get the best performance. Everything can be possible with the digital twin technology. So it can be applied in Formula One or race. As well as Singapore has spent a lot of money for digital twin city of Singapore. It collects all the entire data before 2014 and it will develop the twin city, digital twin city. So these are the amazing examples of digital twin. So we can, it's reliable, reduce risk, reduce cost, maintenance free, and use for customer satisfactions. So that we have to implement this new technology in future to have a better life. Thank you very much.